Hello. We are in Chapter 5, Section 6.5, Solving Quadratic Inequalities. In this video, we're gonna go over problem number 1, in which we are to solve this inequality using test points. To remind you, when we are using test points, it's just a matter of solving the corresponding equation, then plotting all the real solutions on the x-axis. Those plotted real solutions will partition the x-axis into several intervals. We identify those intervals, choose a test point in each interval, and use that test point in the original inequality to check if it satisfies that inequality or not. Then, if it does, the whole interval belongs to the solution set. If it doesn't, then the interval does not belong to the solution set. In terms of the endpoints, that means those real zeros that we plotted, they are only included in the solution set if it's an or equal inequality, as in our case in here. So let's start with solving this quadratic equation corresponding to our inequality. It's already presented in standard form, so we can check if we can factor. And the number -4 can be presented as the product of -4 and 1, and these numbers add to -3. So it factors as x minus 4, x plus 1. Still equals 0, of course, and by the zero factor property, x minus 4 is equal to 0, or x plus 1 is equal to 0. In the first equation, adding 4 to both sides gives us x equals 4, and in the second equation, subtracting 1 from both sides results in x equals -1. -1, of course, is to the left of 4 on the real number line. Those are really the two numbers that we need. We don't need anything else on that real number line, so it's only the matter of aligning these two with respect to each other properly. Let's say we will plot -1 in here and 4 right here, and that partitions our real number line into those three intervals. To the left of -1, from -infinity to -1, between -1 and 4, and then from 4 to infinity to the right of 4. So now it's the matter of choosing test points. Let's say to the left of -1, I will choose -3. In the middle, I will choose 0. And say to the right, I will choose 5. Again, don't pay attention much to the unit lengths on this real number line. It's only the matter of proper placement of those numbers with respect to each other to know which test point belongs to which interval, pretty much. Now that we have our test points, we test them in that original inequality. So for x equals -3, we're going to have -3 squared minus 3 times -3 minus 4 greater than or equal to 0. And we ask whether this is true or false. Now, the square of -3 is 9. -3 times -3 is plus 9. And then we have -4 greater than or equal to 0. We still ask if it's true or false. 9 plus 9 is 18. 18 minus 4 is 14. And 14 indeed is greater than or equal to 0. This is true. And therefore this entire interval from which this test point -3 came will be a part of our solution set. Moving on to the second test point, 0. When we evaluate at 0, obviously all the x terms will go to 0, so we'll just get -4 out of it. And we ask if -4 is greater than or equal to 0. Of course, the answer to that question is no. Therefore, this second interval will not belong to the solution set. And finally, for the third test point 5, we get 5 squared minus 3 times 5 minus 4. And we're asking if this number is greater than or equal to 0. 5 squared is 25. Negative 3 times 5 is minus 15. Then minus 4. Is it greater than 0? Well, let's see. 25 minus 15 is 10. 10 minus 4 is 6. And 6, of course, is indeed greater than or equal to 0. So another check mark. And the whole interval from which this test point came, that means 4 to infinity, is a part of our solution set. As I said at the beginning, the endpoints and their belonging to the solution set depends on the type of inequality. They only belong to the solution set if it is of the form or equal. And our inequality is of the form or equal. Therefore, both of those endpoints belong to the solution set. So I will mark them as solid dots in here. And because they belong, I have to use brackets for these endpoints at -1 for the first interval and for 4 for the second interval. So the solution set is the union of those two intervals, from -infinity to -1, closed at -1 because it includes that endpoint, union with the interval from 4 to infinity with that left endpoint 4 included. And that is the solution set for that inequality.